Hi everyone, I am T. Sagar from CSMC SRT. Today I will explain about the topic of principles of casting process. Principles of the casting process. A comprehensive overview. Explore the fundamental techniques and advanced innovations shaping the world of casting, metal casting. What is casting? Definition and importance in manufacturing. Casting is a fundamental manufacturing process where liquid material is poured into a mold which contains a hollow cavity of the desired shape and then allowed to solidify. Once solidified, the pot, known as a casting, is ejected or broken out of the mold. This method is incredibly versatile, allowing for the creation of complex shapes and large components that would be difficult or impossible to produce using other manufacturing techniques. Its importance in various industries, from automotive to aerospace and even art, cannot be overstated. Casting provides cost effective solutions for mass production and enables the use of a wide range of metals and alloys. Fundamental steps of the casting process. From initial design to the final product, every stage is crucial for successful casting. Mold creation, melting and pouring, solidification, fletting, finishing. Key elements of casting: materials, molds, and melts. Casting materials: a diverse range of metals and alloys like iron, aluminum, steel, brass, and bronze are selected based on desired mechanical properties and application requirements. Mold systems: the mold from the cavity. Ty- Types include sand molds, permanent metal molds, and ceramic molds, each suitable for different production volumes and complexities. Molten metal and melt practice. Precise control over melting temperature, allowing elements and deoxidation processes ensures the quality and integrity of the molten metal before pouring. Common casting methods. Versatility in manufacturing. Different processes are chosen based on cost, material, complexity, and desired finish. Sand casting. Economical for large complex pots. Uses expandable sand molds. Ideal for prototypes and low to medium volume production. Die casting. High precision, excellent surface finish. Uses reusable metal molds under high pressure. Best for high volume production of non ferrous metals. Investment casting. Known for intricate details and superb finish, utilizes a wax pattern coated in ceramic slurry, suitable for complex geometrics and various alloys. Permanent mold casting. Reusable metal molds for medium volume production, offering good surface finish and dimensional accuracy of simpler shapes. Understanding solidification. The solidification process is critical in casting, directly influencing the microstructure and mechanical properties of the final product. As molten metal cools, it transitions from a liquid to a solid state, often experiencing volumetric shrinkage. Controlling the cooling rate and directional solidification is paramount to minimize defects like porosity and ensure uniform, strong crystalline structure. Facts such as mold material, pouring temperature, and the specific alloy composition all play significant role in this complex thermal processes. Shrinkage effects. As metal solidify, they contract. The shrinkage can lead to internal voids or surface Depressions, if not properly compensated for by risers, when feed molten metal to the solidifying regions. Casting defects. Ensuring flawless cast components requires understanding and mitigating common imperfections. Hard tears and cracks occurring during solidification due to tensile stresses prevented by proper mold design and controlled cooling. Porosity. Gas extrapment or shrinkage during solidification reduced by deoxidation, controlled powering, and adequate feeding systems. Surface roughness caused by mold material issues or poor pouring, improved by mold coating, proper gating, and smooth mold surfaces. Misrans and cold shuts. Incomplete filling of the mold cavity avoided by higher pouring temperatures, faster pouring, and optimized operating systems. Designed for castability, optimizing part geometry. Effective design is the first step towards a successful and defect-free casting. These are four types: uniform wall thickness, generous fillet radii, draft angles, strategic gating, and risers. Uniform wall thickness. Minimize variations in wall thickness to promote uniform cooling and reduce internal stresses. Generous fillet radii. Avoid sharp corners by incorporating smooth curves to prevent stress concentrations and promote better material flow during pouring. Draft angles include a slide tapper on vertical surfaces to facilitate easy removal of the casting from the mold without damage, especially in permanent molds. Strategic gating and risers. Design efficient gating systems to deliver clean molten metal and appropriating sized risers to compensate for solidification shrinkage. Quality control and inspection, ensuring flawless cast compartments. Visual inspection, initial check for surface defects like cracks, misruns, and surface roughness. A crucial step, first step in identifying obvious flaws. Non-destructive testing. Techniques such as X-ray, radiography, ultrasonic testing, and magnetic particle inspection are used to detect internal flaws. Dimensional inspection. Using precision measuring equipment to verify that the casting meets specified tolerances and geometric requirements. Future of casting innovations and sustainable practices. The casting industry is evolving with cutting edge technologies and a focus on environmental responsibilities. Additive manufacturing and hybrid processes, automation and AI sustainable processes.